Hello students, myself Dr. Arnab Bhattacharya from Department of Mathematics. Today I will be teaching you the polar curves, the first module for the electrical, mechanical and civil branch students. So let us first introduce what is the meaning of polar curve, why this concept came. So I am writing this, the heading, this is polar curves. Okay. Now all of you know what is a rectangular Cartesian coordinate system. In rectangular Cartesian coordinate system, we represent any point, any particular point, suppose any two-dimensional point we are representing. Two-dimensional point, how you represent? Suppose I am taking a point P, I am denoting the coordinate of the point P as x comma y. What does it mean? X comma y means, suppose I am taking this rectangular Cartesian coordinate axis, this is x axis, this is y axis. Okay. In this rectangular Cartesian coordinate system, this is a two-dimensional system where this is the origin. Suppose any point P I am taking which is having a coordinate x comma y. That means suppose here the point is present P which is having coordinate x comma y. This means abscissa of the point is x and ordinate of the point is y. Means if I draw a perpendicular from the point P on this x axis or on this OX line, then what will happen? This distance O, suppose this point is T, this distance will be having a length of x and this PT distance will be having a length of y. All of you know these things. Okay, this represents the point P in this system x comma y. Now in mathematics there are several different types of coordinate systems, not only this rectangular Cartesian coordinate systems, there are polar coordinate systems and other coordinate systems are also there. In your syllabus in the first module for mechanical, civil and electrical branch, their polar coordinate system is given. In polar coordinate system, any point is represented by two parameters, that is r and theta. It is written as P. P is the point. In bracket we will write r and theta, where r is called the radial distance, theta is called the angle. Now what is the relation between this P r theta and P xy? This we can check. So how to check? Suppose I am drawing once again the rectangular Cartesian coordinate system. Suppose this is x axis, this is y axis. Here the point P is present. Okay, so point P is xy. Okay, here I am writing x comma y. So from the point P I am drawing a perpendicular, suppose PT. Okay, so this is your origin. Now if I join the origin to the point P, suppose I am joining O and P point. So what is the length of this origin and the point P? This length means the distance, OP distance, this distance is called R. This is called the radial distance. And suppose this angle I am taking as theta. Angle means this OP line makes the angle theta with this OT line, or you can say x axis. So this is theta angle and this OP line is R. This R is called the radial distance. Okay, this is called radial, RADIAL, radial distance. Okay. And theta is called the polar angle. Theta is called polar angle. Okay. So these two are the basic things for a polar coordinate. First it comes polar coordinate, then we will go to polar curves. So polar coordinate means any point Pxy, we have to transform this to P r theta. Now what is the relation between these points xy and this r theta? We can find the relation of this. Okay, so I am showing the relation here. On this side I am showing the relation. How to find the relation? So first you see this OPT, this is a right angle triangle. So since this is a right angle triangle, here this angle PTO, this is a 90-degree angle. So this is a right angle triangle. So since this is a right angle triangle, we can easily apply the trigonometric formula. Basic trigonometric formulas we can apply. So if I write from the triangle OPT, if I find sine theta, what will be the value of sine theta? Sine theta value will be, this is your x and this is your y. Sine theta will be PT by OP. PT by OP. That means what we can write? PT by OP means this we can write as Y by R, and cos theta what I can write? Cos theta we can write as OT by OP. We can write cos theta as OT by OP. That means we can write as X by R. All the notations I have mentioned here, this OT line is distance is X, PT line distance is Y, and OP line is R. So cos theta is OT by OP, base by hypotenuse. So from here what we can get? Y equal to R sin theta, and X is equal to R cos theta. This is the basic relation between the polar coordinate and the rectangular Cartesian coordinate systems. You better remember this thing, okay? This formula I am putting inside a box. This is the formula for polar coordinate and the rectangular Cartesian coordinate systems, okay? X equal to R cos theta, Y equal to R sin theta. So this derivation basically coming from this triangle, from this OPT right angle triangle, okay? So next I am showing one more thing, that is whatever is present in your syllabus, that is angle between, here I am writing, this is one of the important theorems, angle between the radius vector and the tangent to the polar curve. So this theorem is very important theorem. Every year or every alternate year you can say this theorem is asked. This is it can come in the 7 or 8 marks, okay? So what we need to find? We need to find basically the angle. Now first you understand what is the statement given. The statement is we have to find the angle between two things. One is the radius vector and the tangent. You see both the things are a straight line. Radius vector is a straight line. Tangent to a curve is also a straight line. So tangent means you know this is a curve. At this particular point we can draw a tangent. Tangent means a straight line. So suppose this is the point P. So at a particular point only one particular tangent we will get. It is not possible to get more than one tangent at a particular point. So same thing what we need to find here, we have to find the angle between the radius vector and the tangent to a polar curve. So first let us see what is the meaning of the polar curve. Now in Cartesian coordinate system you know y equal to fx, we are writing any function as y equal to fx. Y equal to fx means what? What does it represent? This represents nothing but a curve. Cartesian coordinate system, it represents a curve. Suppose I am giving you y equal to x square, or suppose I am giving you y is equal to x square plus 1. Okay, suppose anything I am giving, any function I am giving on the right hand side, this represents a curve. Same way in polar curve means what? Polar curve is represented by the function r equal to f theta. Always remember this thing, r equal to f theta. This is a polar curve. Better here I am writing, this is polar curve. Okay. Now for example, suppose I am telling r equal to I am writing sin theta, or suppose r equal to I am writing cos theta minus 1, or suppose r equal to I am writing log of theta, or suppose log of theta plus 1, this one. So right hand side students, you see right hand sides we are writing, left hand side r is there, right hand side any function of theta. Whenever any function of theta comes, in general representation it is written as f theta. So r equal to f theta, this represents nothing but a polar curve. This is a polar curve. Now what we need to find? First we will show the tangent to the polar curve. The figure is very important for this theorem. So first I will draw the figure. So now I am drawing a polar curve. Suppose any polar curve I am taking. Okay, this polar curve suppose I am representing as r equal to f theta. We don't know what is the exact form of this f theta. We are taking any arbitrary curve r equal to f theta. Now suppose at the point P we are drawing a tangent for this polar curve. At the point P we are drawing a tangent to this polar curve. So tangent, whenever we are mentioning the tangent, it should be drawn at a particular point. Now suppose we are taking the rectangular coordinate system. So this side I am taking x, this side I am taking y axis. Okay, this is your origin or pole also you can say. So now we are joining O and P point. So students, you know this OP point will give you the radial vector or radius vector r. So this angle will be your theta angle. Now see the statement, what we need to find. In the statement it is written, we have to find the angle between the radius vector and the tangent. So radius vector is what? Radius vector is this OP line or this r line, and the tangent to the polar curve. Suppose this curve I am taking that this point is intersecting the x-axis at the point T. So we have to find the angle between, first this thing should be very clear what we are going to find. Angle between radius vector means OP, and the tangent. Tangent means I am taking PT. So angle between these two straight lines, you see these are two straight lines. Angle between these two straight lines we have to find. So OP and PT. So this is your angle. So these angle expressions we have to find. Okay. Now what we need to do? We are taking this angle, suppose phi. Any expression you can take. This is the Greek alphabet phi we are taking. We have to find the expression of this angle phi. Okay. So this is the thing we need to find. Now how to find this thing? So for proving this thing, students, first you have to explain the figure in your own language. In your own simple language you have to write beginning that let us take a polar curve r equal to f theta, any arbitrary curve, this function r equal to f theta we have to take. At the point P we are drawing a tangent which is intersecting the x-axis at the point T. We are joining this OP point. So this OP point distance is r, and the angle that OP is making with the x-axis is theta. This is the polar angle. And suppose we are taking the angle between the radius vector and the tangent as phi. So we have to find the expression for this phi. Okay. So for this phi, first what we need to take? First suppose we are taking this external angle as psi. So what to write here? We have to write, suppose this tangent is making an angle psi with the positive x-axis. Positive x-axis, why it is told? Because you see this tangent, it is making two angles. One is on the left hand side, one is on the right hand side. So positive x-axis you can mention, so that this external angle we are telling, this external angle, suppose we are taking psi. Okay. This is let we are taking this angle is psi. Okay. So psi will be what? You know the external angle, this is a well known result that external angle is always equal to the sum of two internal angles, opposite internal angles. So psi will be equal to phi plus theta. Okay. This results no need to prove, this is a well known result, you can start directly from here, you can write directly psi is equal to phi plus theta. Okay. So next slide I am showing psi equal to phi plus theta. So what we got, this psi is the external angle, phi plus theta. Now taking tan on both sides, suppose I am taking tan of psi is equal to tan of phi plus theta. Okay. So that means what I will get if I write tan of psi. So right hand side, you see right hand side we are getting a formula for tan of a plus b. Tan a plus b formula is what? Tan a plus tan b. Tan a plus tan b divided by 1 minus tan a into tan b. Okay. This formula also you have studied before in your plus 2 level. So tan a plus b is tan a plus tan b divided by 1 minus tan a into tan b. Okay. So this thing we got as tan psi. Okay. This one we are getting as tan psi. Okay. This one suppose I am giving as number 1. Okay. Now one more expression for tan psi we have to find. One more expression for tan psi we have to find, that will be number 2. We have to compare number 1 and number 2. Now another expression of tan psi how to get? Now from the slope concept you know the slope is what? Slope is given by, slope for a tangent is given by tan psi, which is nothing but dy dx. Dy by dx. Okay, tan psi is dy by dx. Means one more expression we can find of tan psi by using this dy by dx. Now how to find dy by dx? So from polar coordinate just now I have shown that x equal to r cos theta and y is equal to you know r sin theta. These two things you know. Directly you can write, no need to prove this thing. These things you can write, we know x equal to r cos theta, y equal to r sin theta. This is the relation between Cartesian coordinate system and polar coordinate system. Now first one you take x equal to r cos theta. What we need to do? We have to differentiate this with respect to theta. So we will write differentiating with respect to theta. We have to differentiate with respect to theta. Both x and y I will differentiate with respect to theta. X I will differentiate first. X you see, x contains two variables r and theta. Y also contains two variables r and theta. So both the things we will differentiate with respect to theta. Theta is the independent variable in polar coordinate system. Dependent variable is r, theta is the independent variable. So remember, we have to differentiate with respect to the independent variable only. Okay. So here I am showing the differentiation x equal to r cos theta. So if I differentiate with respect to theta, so left hand side what I will get, dx by d theta. Right hand side r cos theta differentiation. So r into minus sin theta, cos theta differentiation is minus sin theta. But students, don't stop here, because theta is a function, theta is a variable, and r is also a variable, r is a function of theta. So you have to differentiate that term also. So here it will come plus cos theta into dr d theta. Okay. So once again I am writing, this will be minus r sin theta plus cos theta dr d theta. This will be your dx d theta. Same way I will find for y equal to r sin theta. Y equal to r sin theta, when I differentiate with respect to theta, I will write left hand side dy d theta. Right hand side it will come r cos theta plus sin theta dr d theta. Okay. So same way we have to differentiate. Don't forget that many students what they do, they differentiate only with respect to this theta, but they forget to differentiate r. Okay. So r cos theta plus sin theta dr d theta means u v rule, product rule we are applying. Now you see dx d theta expression we got, dy d theta expression we got. How to find dy by dx? We will just divide it. So here we will write dy by d theta, then whole divided by dx by d theta. So this expression you write correctly, here don't do any mistake. So this will be r cos theta, first dy d theta will come in the numerator, r cos theta plus sin theta dr d theta, divided by, it will come minus r sin theta plus cos theta dr d theta. Okay. Carefully you write in the numerator dy d theta term, in denominator dx d theta term. Okay. So now this side I am showing, this one, this one I am just erasing this above part. So this one, now how to do? Now you see numerator and denominator, this type of expression is coming. This expression we have to simplify. So we will divide both numerator and denominator, dividing both numerator and denominator. This thing you have to write numerator and denominator by cos theta dr d theta. This thing you have to remember, students, cos theta dr d theta. Why we are dividing with particularly cos theta dr d theta? Because we have to bring tan theta above. So in order to bring the tan theta, we are dividing with cos theta. Here sin theta is present, so we have to bring this tan theta. So that's why we are dividing with cos theta dr d theta. Ultimately we have to bring the expression similar to equation number 1, then we will compare. So if I divide this, what I will get? So left hand side dy dx. Okay. Right hand side we will get, now if I divide r cos theta divided by cos theta dr d theta. So that means it will come r d theta dr. Cos theta will get cancelled, r by dr d theta. Now r by dr d theta means, suppose here I am showing r by dr d theta. This is nothing but r into d theta dr. You can write directly, or if you wish one more extra step you can show r d theta dr. This one will become what? Sin theta dr d theta by cos theta dr d theta. So this will become simply tan theta. And denominator will become what? Minus r sin theta by cos theta dr d theta. So that means this one will become minus r, then this one will become tan theta into d theta dr plus 1. This one last term you see, cos theta dr d theta divided by cos theta dr d theta. This will become 1. So this division you have to do very carefully with cos theta dr d theta. Both numerator and denominator you have to divide. Now here I am removing this expression. Now you see what will come, dy dx is equal to, now whatever expression I got on the right hand side, you have to arrange it properly. So if I arrange, I will get r d theta dr, this is d theta dr plus tan theta, and in denominator first I am writing 1 minus tan theta I am writing into, I can write bracket I am using r d theta dr. So this is your nothing but this dy dx means this is tan psi. I told you this is the slope of the tangent. Slope of the tangent formula already you know, this is dy by dx. This is represented by dy by dx. So r d theta dr plus tan theta divided by 1 minus bracket product of two terms tan theta into r d theta dr. So that means basically what we are doing here, this expression, whatever these expressions you got, this expression you have to arrange it properly. Two terms will come, one is r d theta dr plus tan theta, and denominator it will come 1 minus tan theta into r d theta dr. This one you can give number 2. So one expression I got for tan psi, this is number 1, another expression we got for tan psi, this is number 2. Now you just equating or comparing also you can write, equating equation 1 and 2. So if you equate equation 1 and 2, you will get the expression from the right hand side, that is the tan phi expression. Tan phi expression will be r d theta dr. So this is one well known result, and this theorem is very important to find the angle between the polar curve. Sometimes in exam the question comes, prove that cot phi is equal to 1 by r dr d theta. So same result, exactly same thing, first you prove this tan phi, then just one more line you write cot phi is equal to, just take the reciprocal, cot phi means 1 by tan phi, 1 by r dr d theta. So when we will do the problems, we will show that how to find the angle between two polar curves. In that case, this tan phi theorem is used. Okay, in that case when problems will be asked, no need to prove the theorems. This theorem when it comes separately, you have to show with this diagram, you have to prove the theorems. Okay, thank you students.